Hello again, my name is Avkash, and today in this tutorial I have brought you the simplicity of CNN explainer and the complexity of any neural network. In this tutorial we are going to learn the common and very popular MNIST digit recognition problem, and using the CNN explainer we are going to learn how the neural network solves such a complex handwritten digit recognition problem. The neural network for handwritten digit solution have taken from the Keras and from its data ingestion all the way to the model evaluation. All of those steps in between are explained in details, and where applicable we have used CNN explainer to understand how the data transformation as well as the deep learning is happening. This tutorial is designed especially for the beginners or the early adopters who are learning neural networks and find some complexity to comprehend them. So let's get ourselves started. So in this tutorial, our objective is to look at the MNIST dataset and the solution related with MNIST problem using the Keras. So first, I will show you that the Keras website, you can already get the MNIST solution using the convolutional neural network, and this solution is already available in front of you. So we are going to use this example, and we will use this example in the Google Colab, and we will take this example and dissect it at line by line, and wherever needed I will be adding a lot more new code to it. So if you are the beginner or you are starting your career in deep learning and you are still learning neural network, you can get in-depth information related with everything what happens in this example. So starting we will have 20-30 lines of code, but by the end we are going to have almost 100 lines of code in this project. So let's get ourselves started with the coding first. I am using the Google Colab. I always say if you are not using Google Colab, you are losing a lot. Must use Google Colab. It's a free resource available for you to just enjoy, learn. So I will be creating a new Google Colab document here. So very first time when you create this Google Colab, it gives you a virtual machine, and this virtual machine has some RAM available. So it also has the full file system. Like it's basically a Linux machine with about, you can see that this machine has good amount of RAM available for you, and it also has about 60 gig space available for you to play with it. So it's a really great way to start working with your Python project. Deep learning and non-deep learning, there is a lot more you could do here. You name your Google Colab, so I will call it Keras Mnist detailed. And if you select this save option, this is going to save this document back to the Google Drive where it was originated. And if you look into here, if I try to reload this page, the detailed Keras Mnist detailed document, and that is available here. So this is the easiest way for you to get started. Next, we are going to import as suggested by the Keras documentation. So we have imported it. Look, I haven't installed anything. Keras, TensorFlow, majority of the deep learning related Python packages all are ready for me to get started just by few clicks, and I'm ready here. Next step, I will be taking this whole code, that is prepare the data section. So here is the prepare data, and I will add same prepare the data section. After that, we are going to create the model. So this is just a definition of our convolutional neural net. So let's add the, so here is our code and here is our text. So this is
prepare the model. And finally, the last step, we are going to train our model. And at the last, evaluate our model. Here is our, and final section was, I could have copied the code, everything, but I just wanted to create in front of you. So we have pretty much brought all the code related with Keras and everything was here. And we are going to, if I clicked here, I could have got the GitHub source, or if you view in Colab, but I really wanted to show you the pieces split by split, the way it is. So I wanted to create everything from scratch. So let's import. We are preparing the data. As you could see here, that data was downloaded from Keras location, which is the Google storage, and it's downloaded at our local machine. And if you look into here, this is the machine which is given to us by Google Colab, and in the content folder, the sample data is the place where your content will be downloaded. So if you are trying to upload something, you can actually upload content directly from here. So if you would want to upload a file locally for whatever reason, you can select whatever directory you want. You can just right click and it will be uploaded. Similar to that, if you would want to download a particular file, you select that file, right click, and you can download that content from Google Colab to your local machine. Just really very simple. Or there are a couple of other APIs which you could use using the Python Jupyter notebook also. So now we have got the data set available, and at very last, this is what been print. It means our data set is ready, and now we can prepare our model. So this is our model. Model is ready. Here is the model summary, and as you could see, this model has 34,000 parameter. Looking into that, we can say there is the input, then there is a convolutional layer, and so there are two convolutional layers here, and the filters are 32, kernel size is 33, activation is ReLU, and convolutional 2D, when you are using, if you do not define that use bias equals false, by default bias is also used. Here we are using the max pooling, and pool size is 2. It means if you do not change the stride value, then stride will be 2. So I'm giving you various new keywords here: filters, pooling, bias, pool size, stride, kernel size. These are all could be the new content for you. If you think that this is very new to you, does not make any sense at all, I have a good solution for you. I would want you to go visit my repo called Python projects. It's a public repo. So ProdRamp Python projects. In the Python projects, I have a folder called deep learning. In the deep learning, you might be able to find a step-by-step guide to get your journey related with neural networks. Here, you can start with very first, and these are all video tutorials. So if you click any of them, you will be able to get the YouTube tutorial available for you to get started. And there are several of them. You start by one. So as I add new tutorial, and if they are sequential, I add the link directly to here. So video 1, video 2, where you will learn building your very first tutorial, then video 3, then video 4, where here you are going to build your very basic perceptron and feed forward network. Then very first CNN you are going to build here. Here you are going to go a little more deeper and learn about how parameters a different layer, and couple of new videos also came. They will also be added here, like a CNN explainer related video, how you could visualize your convolutional neural network. So please, if something looks new to you, here what we are doing today, you can get yourself ready, then come back in this tutorial. Or if you already know it, then it's perfect because we are already doing it. So here we haven't trained the model. We just defined our model, and these are the layers. We have decided that these layers will be used in our model. Next, here is the training. So when you are start going to train your model, you have to have these two steps separated. I always separate them here for a while. So okay, so I have separated. So here we are defining the various two very important parameters related with our model. So first, batch size is 128. I will explain what is it. And epochs means train 15 times. So this is going to train our model 15 times. And then compilation for the model is basically setting the parameters for our model as defined here. So our optimizer is Adam. Metrics, we are using accuracy. You can add other model metrics such as RMSE, MSE. There are a variety of metrics related with your problem. They can be added here. So if we have already run that, so let's set up the batch size and epochs. We have added them. Then we are compiling our model, and you see nothing happened as of now in terms of progress. Our model parameters are all set. As soon as we are going to run the model.fit, that's where the real training will start, and we are passing our training data. Here we are also passing the batch size. This is the batch size. Then epochs, how many times we need to train, whole set of the input data, and our validation split. It means in the training data, when we are passing this xtrain data, split this data based on validation split. It means 10% of data keep it for validation, and remaining 90% of data will be used for training. So this will be our model fit. So I will run it, and reason I will run it while training is going on, we can actually get our learning started. So I have started the training. Epoch 1 is started, and you see here that because this data is really very small, that not that very big, and 15 epochs will be done very quickly. And as you see here, that is asking you that it's gonna do the 422 times of something, and it's running. So we will learn that the relationship of this batch and this count, how it's really came. So there are so many things to learn in this example. So if you are new, as I suggested, you are going to have a lot more fun, or if you are starting your journey with deep learning. For right now, because this left side tab is not needed, so I will close it. So we will have a lot more real estate available. So epochs, we decided 15. 1 is already completed, 2, 3, 4, 5, and this network has already been decided, and I think the Keras team already did a lot more research. So they came up with this particular network configuration, which was best suitable to solve this MNIST problem. So if this is the best decision, if you would want, you can change this. If you would do not like, you can change kernel size, you can change pool size, you can change the inputs or the filters. There are so many things you could do, and you can experiment, and you will learn how bad or how good your results are according to your changes. Let's go back to start, and we are going to learn each and every line in detail. That why it is, if it is, why it is written, it is why, if something is written, why it is written. I will split this whole thing, and I will take this, cut it out, and I will add a new cell here, and I will cut this too, and 2 steps. So here we have number of classes. Number of classes is related with depending on what your problem is. In MNIST example, our objective is that we are creating a machine learning, especially with convolutional neural net solution, so that we can identify handwritten digits 0 to 9. So your digits are 0 to 9. So if you write any number using hand or type, whatever it could be, you are writing a number. If you could identify each individual digits, you can read all the number depending on how big it is, correct? It means that our number of classes are 10. If you are thinking what is MNIST problem, please visit to MNIST problem, and there is a lot more data you are going to get related with MNIST, like where this problem really came originally, what was the team behind it. But essentially what we want in this tutorial is that you should understand that minimum your knowledge should be that MNIST is the problem related with handwritten digit identification, and we are creating the deep learning convolution net solution so we could identify what digit it is. So for that, there is a lot more data was collected. So that data we are going to learn about it and what is inside the data, how the numbers are written, and then going forward. So number of classes 10 should be clear at this point because our results are 0 to 9 we are going to predict. So total number of 10 classes. So that's why our result will be the 10 class. At this point, I will also open the CNN explainer, which is a very nice utility to see your visualization of your CNN network. So this is not what MNIST is going to MNIST is, because these are two separate problems. However, a little visualization is going to help you a lot while learning the MNIST. Just today, I have launched a new tutorial about CNN explainer that is already available, and it's just going to be previewed today. So while you will be watching this tutorial, you can actually watch my whole CNN explainer video, and that is going to make you learn immensely about neural networks and the convolutional neural network. Time to time, I will come here in CNN explainer and I will try to show you a couple of things what is happening in this Keras Mnist example. Okay. So foundation is getting ready for us. And if this tutorial is getting a little bigger, that is okay, because my objective is to explain as much as details I could add for you, so you do not have any question left. If there are still question left, please contact me through this video comments and I will be able to provide my assistance. Remember, our problem is we need to identify the digits. So when you are going to write those digits, we need to have some kind of idea that how big the numbers could be, correct? So first we need to train our model. It means our training data already has these size. So in this example, the input shape is defined as 28, 28, and 1 means is a channel. So when you are trying to use the machine learning or deep learning for your image data, you always need to provide two important things. Your input data size, it means your image height and width. So it's best that you take all of your input images and make sure 100% of your images, the input size is identical for all. So that is very important because it will help your training system to learn better. First. Second, you need to provide the channel. If your images are black and white, like grayscale, then your channels are 1. But if your images are color, then you can provide the channel 3. It means RGB. So input shape, because when the neural network is going to study your image, learn about it, features, if it is RGB, it's going to split that image to 3 different separate channels and learn separately. So it is very important for you to provide the input shape. If we look into the Keras here, the data set which is prepared by this Keras team for us to use, they have already set it up, all the input image in the data as a 28 by 28. So 28 pixel height and 28 pixel width. So that's the reason our input shape is 28, 28. So Keras already has this utility where you can collect a few data sets which are already being hosted for you to learn deep learning, neural network, CNN, anything Google and TensorFlow team wants you to learn. So when you are importing TensorFlow Keras.dataset.mnist, this API already has this function called load data. It means give me data wherever it is hosted to where I want to perform the training. So this API has everything pre-built for you. It means when you run this thing, it will return your data in this format already. Otherwise, if you would have done this thing, everything from scratch, you would have to collect all your training images. Just an example, if you are trying to create a training system to identify cat and dogs, then you need 100, 200, 500 cat images, then you need that many dog images. Then you make sure all the images are in same size. You are training with 128 by 128 or 128 by 256, you need to make sure images, all that work you have to do. Third, you need to make sure the labels are correct, so cat and dogs are correct. Then you would need to also create the labeled and unlabeled images. Means that so that you really know that training images and test images are separated in a way that some images you have already labeled them training, and then rest you already know that these are the images going to be test, so you don't want to pass them as a training. So you need to separate them in your source data. So now what we could do is that we will reload our data after we have completed the training, because when this training happened, the training data has been changed. So in order to understand our example correctly step by step, our best option would be that we can restart everything from here. So the data is in normal and original shape. So number of classes are 10, input shape is 28, and we are going to pull the data again. So now our X train, Y train, this data, and X test, Y test, all data is as it is, as we were expecting to start with. So very first step, we need to understand what is X train here. So X train dot shape. As you could see here, X train dot shape shows that our data is 60,000 samples of size 28 by 28. It means if we would try to check the very first item in this list, there will be first item with 28 by 28, or if we look into the last one 5999, that will be the 28 by 28. If we go more than that 60,000, you are going to get exception here, because 60,000 record with index 0 to 59999. So if we look into 10,000, we will get number here. Similar to that, if we would want to know what is in X test, let's test first shape, you will get 10,000 record of 28 by 28 size. It means similar to training and test data. Next, we look into the Y train. Oh, I should call it shape. And as you could see here, 60,000 record to match the training data, which is 60,000 record. So for each record, there is a label associated with that. So whatever the first recorded, the label is it, the Y train here. Similar to X test, there is a Y test available. So there should be 10,000 records similar to X test. So let me move this guy there. So now you have X train, Y train, and X test and Y test. So 60,000 record, 60,000 record, 10,000 record, 10,000 record. So training data and its label, test data and its label. So far it's clear. Now if you would want to see what is the very first value into the Y train. So let's look into the very first value. So it say that, sorry, what is the value of, or maybe we can just leave it shape here, and now we can come back here and say, okay, the shape, and just look into here. So the X train 0 value is, it's a value, so 28 by 28. So there will be array first 28, then 28, so 28 times 28 rows. If we would want to see this value, we would need to, so shape is 28 by 28. So what would be the best if we have ability to see this value, what is there, correct, in image format? Because now we look into the Y train value. Let me see the Y train of 0, and you say this value is 5. It means this value X train 0 of 28 by 28 should be the 5 value. In order to see this value, we can take the advantage of matplotlib. So here I have added this matplotlib pyplot, and we are going to reference this module using plt So we could use PLT here, say plt.imShow, and pass our whatever we want to pass, so xtrain 0, and there you go. So it's a colored image. It means it has RGB channel. However, in our training, input shape is being set as 28 by 28 by 1. It means when the training is going to happen in this neural network, the color channel will not be used because color channel is given as grayscale. So whenever the training is going to happen down the road here, input shape, it is going to take the grayscale channel. So if you would want to see this grayscale, you can change the color maps. It's called the C map equals. You can say I would like to see gray, how it look like, and same image is gonna be in grayscale. So you have option to add this grayscale if you would want to here. So I'm gonna use this, and so this is 5. It means if you take xtrain and if you say what is the 10,000 value, it's 3, then we can say okay, let's validate if it is 10,000. It's definitely 3. So this way you can validate any of the number. If you would want to say that you want to test your test value, I will create 2 more cell here. So we can say plt.im show, let's use the x test and use the 900 value because there are x test. This is 1, and now if we try to say what is the y test value of 900, the label is 1. So you have ability to see your data, all 60,000 training record and 10,000 test record. So training data related part is done. Now we are going to see what happens in next these 2 lines. Again, I'm slow and I'm giving you as much as detail because I want everybody to learn as much as possible. So here we are changing the image data inside, and I will show you what is going on. So I will give you example of one image. So x train the image number 100 or 1000, let's use. If you look into this image is the value between 0 to 255 for every pixel, because that's where you are going to get your RGB value for that image. So for 28 by 28 image, you have row number 1 where 0 to 255, then row number 2 0 to 255, and depending on these numbers you are going to get your value of that image. So this is 28 by 28 image size. So what we are trying to do is that we are taking this data and we are converting it to make sure this value is between 0 and 1, every value. In order to make sure the machine could understand, it has to be changed, and by changing that the number changes, and then every value which is 0 to 255 is between 0 and 1. So for the training data we perform, and for the testing data we perform. We do not need for y because y just has only label at this point. So we ran. Now we can look into the changes happen in our xtrain data. And if we look into the xtrain, what was the value? It was 900 number. So we look into 100 or any number we could see. Now you see that every value became between 0 and 1. So that's the reason this operation was done for training and test data. So now you can get an idea that we are just dividing every number from 0 to 1, and that's where if some number is 255, it will automatically become 1, and all values are float. And same thing is going to happen with test 2. So just for sake of completeness, this is what we have done for x test. So hopefully that clear, and what I'm doing is that I'm just changing these value to the shape so that when we save this Jupyter notebook, it just does not take too much space. So that's the reason I'm just making it small. You get an idea why we have done that thing. So far everything is okay. Now we are going to work on this step. So what these 3 lines for printing. So we are not worried about that. We are only taking these two lines. So now if you see here, the comment says that make sure images have shape 28, 28, 1. Because our input shape is 28, 28. Our defined shape is 28, 28, 1. It means in the input data must follow the shape as designed by the architect of this neural network. And that is not, because if you look into all the images are this shape, and if you look into just for xtrain dot shape, 60,000 records of 28, 28. So NumPy utility has the expand dimension, where depending on which axis you would want, to add the dimension, you could add. So if we try to add the dimension here, -1, we did this way, and now you see here that the xtrain shape became 60,000, 28, 28, 1. One dimension is added here. Same thing if you would want to print the value of y, you can also say give me the x test here, and we don't need to perform this again. So we could just add this thing into the new cell and we can get the value of. So xtrain shape, xtest shape, and you could say here the very first we have 60,000 and 10,000 samples. So hopefully this exercise should be clear at this point. We started with the images 28 by 28 size as a start here, very early classes, and then input shape was decided by the architect of this neural network. That's the reason we had to take these images which came from MNIST data load, which the utility provided by the Keras team. And finally, at this point, our input size is set as a 28, 28, 28 for every image and all 60,000 images. At this point, we are performing another exercise on our Y column. So if you remember the Y columns, we have the 0 to 9 values, whether it's a 5, depending on whatever in X training data. Similar to that, we give the label for every 0 to 59,999 images, their correct label for training and test. So what we are trying to do here is that we are trying to convert this to categorical data. We can look into ytrain.shape. So 60,000 record. And if you look into the very first data, it was 5. If you look into the 59,999 data, it was 8. It means these value, which is 0 to 9 in this Y train and the Y test, what we need to do, we need to convert them categorical. So here the categorical conversion is happening. Conversion happen here. Now we can look into what is Y train look like. Here is our Y train. As you see here, you can look into what is the Y train value of 0. Now you see here that depending on your number of classes, so your output is 10 classes. So depending on 10 classes, your 5 became 0, 0, 0 all the way to 1. Like the 0, 1, 2, 3, 4, 5th. So 5th item. If there was a 9, then this will become 1. If there was a 0, then this will become. So all the values in your Y column has been changed to categorical here. If you look into 0 here, this is the value 8, 7, 8, 9. So this must be 7 value. So 0 to 5, 0 to 9 values became 0 to 9, but in categorical, because our object is classification. We are not doing binary classification, because binary means there are 2 classes. So we are doing a multi-class classification here for 10 classes. For that reason, we have converted our Y part of training data and test data to the categorical. So hopefully at this point, our training data is ready to go for training. We have performed everything, every step needed in order to make it ready for us. Next, we are defining our model. So I will just run this one more time. It's because we are already going step by step by step. So here is your model summary. So when you take this out and add the new cell here, now, so if we define your model, there will be no output because we just defined our model, and then model summary is the command here which will give us the model. So if you would want, you can actually name these layers. So there is a name, you can actually call them whatever name you would want to set their name also. If you do not give your name, it will give automatically these convolution 2D4, because if I will try to define one more time, and if you look into the summary, this will become the convolution 2D6 because 5, so 6, 7, because there are two convolutional 2D layers. So reason we are using convolutional 2D because our input shape is 28 by 28, but it's a grayscale. So this is a very common practice. Then you can use the convolutional 3D if you would want to process the 3 color images, RGB. If you want to process gray color, then you can use convolution 2D. Input, we are using the 32 filters. So it means that what we are going to do is that we are going to take the 32 of these filters to start with in first layer, and kernel size will be the 3 by 3. First convolution will happen. After convolution is done, then final result will be passed through your activation, which is ReLU. And as I mentioned, this is very helpful for you. This documentation talks about what is ReLU here and everything. As you see, there is a ReLU and there is a softmax, and depending on our objective, you see our activation is softmax in the last layer. So this is going to help you a lot, and I have already created a video to explain more, but my target would be that I could explain this thing in really detail to you. So this is our network we have decided, and this is our network look like, and here are the total number of parameters. I have another tutorial which talk about how to calculate parameters in detail. So that is, we are not going to put it here because it's gonna add too much content to it. So model is defined. Now we are going to set the batch size and epoch. So I'm gonna explain you batch size here really very quick. So let's set the batch size. And now let me add one more text here. So your input image size is 60,000. So your input image size is 60,000. Your batch size is 128. However, if you look into your model fit here, your validation split is 0.1%. It means this data, which 60,000 here, it actually based on 0.1 validation split, it became 6,000 record for validation and 54,000 records for training. So if based on your batch size, you need to take 54,000 record and divide by 128. So if we take 54,000 divided by 128, that, and use the calculator, you will get 54 divided by 128, you are going to get 422, total 422. So for that reason, you are getting here 420 times. So remember when we started this training very first time, you see, for every epoch, we ran 422 steps. So each step we took the, based on our batch calculation, and we took that many record. It means for every iteration, 120 images being pulled into the training, and we did 422 times so that we could process all 54,000 images. Remaining 6,000 images were used for validation. So hopefully this is clear for you, and epochs 15 means the training will be done for 15 times. So these two lines should be clear for you, and this one is also should be clear to you. Now the compilation. There are various optimizers available. So we are using Adam optimizer here, which is like kind of really high choice when you are trying to process the images, especially for neural network. Other optimizers can be used for other problems, maybe when you are processing the transactional data. The loss method we are using is a categorical cross entropy. because one way you can look into our target is a multi-class classification problem. So the categorical cross entropy loss is chosen here, and the metrics, when the training will happen, we want to see the result in the accuracy. So that's why you are going to get accuracy. Some developers or some data scientists will look for MSE, MAE, AUC. There are several parameters. Again, our scope is this particular problem. So we are focusing why we are choosing these options. So this model.compile has been decided. Now what's going to happen is that training will start again. So we have already done the training, but when this training is going to be happen, I'm gonna come back here and I'm gonna explain everything here, what is happening in visualization, so you can get a little idea of what is going on here with reference to this particular problem. So I will perform the training again, but in this time I will change the epoch to maybe 5. So it will be done very quickly here. So I have done 5 epochs. I will start the training, and not only that, if you change this validation split to 0.2, it means 20% record. It means 6,000 became 12,000 validation, and this became your 48,000. So 48,000 divided by 122, that many values will be there. So let's do it. So we already have that, and we will do only one epoch, just use 2 epochs. So we are doing 2 epochs. The split is 0.2%, and as you could see here, there is only 375 times. And if we look into 48, so our result should be 48,000 divided by 128 and 375. Next time, if we change this value, and we will say that we would want to change our batch, rather than 128, we want to have 64. So in same example, 48,000 divided by 64 equals 750. So it will be 750. So what we will do, we will use the same example, and remember, the batch is depending on what is the throughput your machine is going to give you. So if you are using the 64, but your throughput can be bigger, you are basically taking too much time because you are misusing your resources. Because of our change, so this one took 37 seconds, and this value took about 37 seconds. So like about 38 seconds took each step at this point in our 128. So if we change this to 64 batch size, and if we try to perform this same thing, and remember each epoch was 38 seconds. Now we do experimentation. Now for 750, remember, because it became 375 became 3750 because we have reduced our batch to half. So less number of images are going through with resource with our system. So first epoch took 40 seconds. It means even when we change the batch size, our time was almost identical. So now you can get at least good idea the relationship between the batch size and the input data and the validation split, how it happened. Sometimes you do not use the validation data. You use the cross validation. It means you are not dedicating the validation data from your input data. For every iteration, cross validation technique is used, and that changes another math. So if you understand what is I mean the cross validation, I hope you can get an idea that how this math is going to play role for that scenario. So we have checked this thing, and when this training was happening, let me look into the CNN explainer and explain you what's going to happen at this point. Here our input data was 28, 28, correct, and 1. And when we are processing here, our data is 26, 26, 32. How that change happened? We started with the 28, 28, 1, and then here at this point, our very first step will be 26, 26, 2. So let's come back to CNN explainer. If you see here, the input data is 64, 64, 3, which is 3 channel, 64 by 64 by 64 images. But after the convolution happened from input to here, the data became 62, 62. And if you look into, this is what convolution happen in a convolutional network. So similar to here, we are taking the 28 by 28 image and we are performing the 3 by 3 kernel size convolution. So here the 3 by 3 convolution happen for 28 by 28. So think like this is 28, this is 28, and for each 3 group of pixel, height and width, we are performing the convolution, and when this convolution happen, we take the mathematical value and output. So if you are taking 3 by 3 matrix and getting 1 out, definitely at last, if you have 30, you will lose always 2. Whatever n you have, 3 by 3, you will always lose the last 2, like your minus will be 2. So here 64, 64 became 62, 62, height and width. Similar to our this example, your input was 28, 28, that became 26, 26. Next is you are taking the filters here, 32 filters. In this example, the filters are taking the 10. So that's the reason you are seeing the number of filters are 10. Similar to our example, the 32 filters will be taken, and that has been done for 32 times. So for that reason, when this convolution was happened, it became 64, 64, that perfect. However, next step going to be the ReLU is going to happen, as ReLU is going to happen here. So at this step, 62, 62, 10 is your number of filter. In our case, 62, 26, 26, 32. 26, 26, 32. That is what your output shape is. And if you would want to check 32 and parameters are 320, that is because your parameter count is you use bias. So we are using bias, and we have 32. At this point, we have 32 filters. So 32 times 10 is your 322 parameters at this point. So that's why you are and use bias. If you would not have used the bias, you are going to get not that number of parameters. Okay, so this 26, 26, 32 should be okay. And now we also need to make sure that you understood the part of ReLU. When this ReLU happened here, as you see here, that what we are trying to do, ReLU is not a reduction. ReLU is basically the taking the numbers. If you have negative number, it will convert to 0. If you have positive number, it became as it is. So if you see here in this example, some of the negative values, the return is equal 0. So look into here, if this is negative, return will be 0. If it is positive, the positive value. So you see here, all the negative values are 0, and all the positive values are getting the values here. So for that reason, you are getting this output image, which is after the activation. So this going to happen for 32 times because of 32 filters in our example, and there is no reduction in number of image size because that is fixed here. So at this point, you have seen the convolution at this stage and activation in this stage, and now it is a fully connected layer. So now you have 10 filters and 10 filters. So 10 input in this level is going to go the 10 for the next layer. In our example, there is a pooling here. So we now need to do the pooling. So, but this design does not have the pooling, so we need to look into the pooling part. So I will take the example of here. So what happens here, that your input is 26 by 26 and 32, and now your output after the pooling became 13, 13. So now we need to just quickly understand what is pooling. So pooling, you have the pooling kernel or pooling size, which is 2 by 2, and you also have the stride. Stride means when you are doing pooling, what is your stride? If you don't define a stride, the pooling size actually became the stride. So I will tell you here. Here is the pooling. So your image, think in our example, our image is 26 by 26. That is our input here. Make sure 26 by 26 here. Mentally think it is a 26 by 26. Then you have a pooling 2 by 2. So for all those images, we take 2 pixel by 2 pixel, and our pooling choice is max. It means out of these 4 points we have taken, whatever the maximum value is, take it. So this, for each 4 by 4 set, you are going to get 1 max pixel value. and that's what you are getting. The next comes the stride. It means if you are changing the stride, if your stride is same, you're gonna jump to next. If your stride if your max pooling size is 2 by 2, but your strides are 3, it means you're gonna jump one pixel. If you say stride 4, then you're gonna jump 2 pixels. So you are gonna lose a lot. Same thing in down size 2, because your stride is going to work both way. So here the stride is same. It means we are not jumping anything. We are taking 4, 4, 4, 4, 4, like a 2 by 2 pixel. So depending on 2 by 2 kernel, when I say kernel, I'm talking about the pooling kernel, and same stride, you are always gonna get half of the image size. So if you take a 60 by 60, your output will be 30 by 30. In our example, our input is 26 by 26. Our output gonna be 13 by 13. That's why I say output shape. If you have pooling 3 by 3, then you are going to get 1/3. So if 60 by 60, you're pooling 3 by 3, you are going to get 20 image. In our case, if just an example, we change the pooling here to 2 by 2, for example, this result is automatically going to become what? Because 3 by 3 is that case, so you have 26. So 3 by 3, 3 7 are 21, 3 8 are 24. You will get 8. Because after 24, you are only gonna get 2 pixels. But your pool is a 3. So both 2 pixel, they will be discarded. So if you say I would want to change this to 3 by 3, and if you define your model, and if you look into the summary, you see here your input, so your output after 26 is 8 by 8. So you can get an idea. I don't want to change everything, so that's why I showed you for example. Now I'm going to put back to 2 by 2. So our example is exactly same. So now we have completed the pooling part. So you got the idea of max pooling. If you do average pooling, then out of whatever your pooling size box is, it will be average of all those values. What if somebody want to do sum? Then you sum everything and you put it. So whatever math you would want to use in the pooling, you could apply it. Most popular poolings are average pooling and max pooling. So pooling is done. Now next we are taking the input, output of this layer is going to fed into in the convolution. So now we will take the 13 by 13 image and we are going to do convolution, and then after the convolution your output is 11 11 64. How it happened? Because the convolution, we are using the kernel. So convolution kernel is 3 by 3. It means whatever input is going to be, we're gonna lose that kernel size, height and width. So our kernel size is 3 by 3 and input is 13 by 13. So definitely we are going to get 11 by 11. We have already looked into initial how it happened. So just if you want to understand, always look into this image, very first one. Let me say here, sorry. Okay, now you look into here. And then that's gonna show you the convolution happen based on your kernel size. So I believe that it's very easy to understand that 13 by 13 based on 3 by 3 kernel here, and with activation ReLU, you got 11 11. You must ask what is 64. 64 is the number of features added here. And in our example, if we do not see this way, this is the 10. If this is our very first layer, cross this out, because in our first layer we are doing convolution, activation and max pooling. 3 things we are doing. So in our example, if this is our example, this will not exist. This will be our image. This is what happened layer number 1. And same thing, the layer number 2 is doing convolution, activation and max pooling. It means this will not happen with us directly. It's going to happen this here. So this is 10, this is 10. In this example, in our example, this is 32 and this is 64. So 32 input, 32 inputs in your previous layer is going to be 64 output. So 64 connections is going to be there for the full connected layer. So hopefully that clarifies you that part. And parameters, please check out my several tutorials previously. They all talk about how you could calculate it. So after 11 11 happened, then we need to perform the max pooling. So the input 11 based on 2 by 2 pool size and the same stride, you're gonna get 10. 5 2s are 10 and 1 will be discarded. So your image became 5 by 5 and 64 is input. So up to here everything is clear. After After that, the next step is flattening. So what flattening does, there is a very good example here for flattening. So you see here that your image was 13 by 13, so 169, and you had 10 features. So based on that, it became 1690. In our case, we have 5 by 5. So 5 5s are 25 times 64. So this is a 1600. So our flattening is a 1600. There is no reduction. It's just image was the 5 by 5, and because of 64 features, that many outputs are. So that's why you are seeing here. That is what is happening for every output, for every feature. So you see here, this is exactly. And then because all of our layer, we are using the use bias, we haven't changed the use bias. I can just very quickly show you. You go to here and then parameter TensorFlow. You look into the documentation, you will see that by default, the use bias is true. This is a default value for the use bias true. If you will not use the bias, use bias Boolean, whether the layer use the bias vector or not. So because we are defining, we are not saying use bias is false. So we are using the use bias. For the reason, this bias is added. So that's why you see here bias value. Sorry. So you will see in this area the bias value here. And as you see here, these are the weight. We are seeing the weight for every, and then finally the bias is being added. So we have seen flattening. In this example, the dropout is not happening, and dropout is basically the depending on whatever your dropout value is, when you are taking the output, you can reduce that many connection. So at this point, whatever your number of connections are, if you use a dropout here, at this point, that percent connections will be dropped. It means your network will be smaller. So that will make system work fast. So in this case, if you comment this and you do the training, you will see that your training time will grow because of you are dropping some of the layer. And then you might find some documentation that dropping out is not a good idea in the CNN, and there will be lots of content available there. And the reason is that because if you say you are dropping out, so the input from one layer to other layer, the full connectivity will be broken. If in this case, if we have 10 of these points, we drop out 50%, so only 5 connections will be created, only from 5 of these features. So dropout will reduce the number of connections, that will reduce the total working processing happen in your network. So here we have dropout, which is not visible here, that's okay. However, the final layer is our dense layer of the number of classes, and our activation is softmax. That is also visible here because you could see that our classes here is a 10 classes and here is a softmax. So you can see that softmax is whatever input is depending on your classes. So if this was our example, these values should have been 0 to 9. This logit value for each, and then if you look into here, you could see that connectivity is coming into the number of connections for each one. So depending on whatever the correct value is, so our input was cup here, so espresso is the highest possible value. You see the logit value is 8.6469. For rest of the values, the logit value is really very small. So this is the softmax, and if you look into here, for each value you are getting the total. So is this like you say 2.97 for ladybug, because this is what is selected, so that is being taken, and this is the total of 0.30. So there is a lot more math going inside, and I'm not trying to go a lot more deeper, but hopefully you can get an idea that everything what was happening here from all the way. So number of classes, we took 10 classes, activation softmax, I showed what is happened, and based on that is your result is going to be available when your model will be created. So this CNN explainer was very helpful for us to understand for our MNIST problem, and once your model is ready, you can evaluate your model using the test values. And what happens in this method is a very simple check. The model is used on given data and it predicts whatever result is. So for all 10,000 images being evaluated by the model here. So model will say, oh, first image is 5, second image is 7, everything happened. And now we actually have the y-test, we already have a column. So we know what is in each number. So if the models say first image is 5 and y-test say first image is 5, it means it's correct. So what happens is that all the 10,000 values in your test data has been evaluated by the model, and model result and actual result are compared and percentage is checked. If model predict every value correctly, then your y test will always gonna be 100%. If there is a one value missed, then you will get one, like 100 minus 1. Like out of 10,000, 9,999 results are correct, only one is wrong. If 10% wrong, then you can get an idea. So the accuracy is collected based on this evaluate method. You provide the test data, you also provide the labels. Evaluation is happening only on the test data. And then real values are used to get the accuracy of your result. So I hope that this whole explanation for the Keras Mnist detailed should be very easy for you to now understood what had happened in this MNIST example. What I will do, I will save this document to my public GitHub repo, and if you know how it is done, you can take this and you can say save a copy in GitHub, and you connect your Google Colab with your public or private GitHub repo, and you could set it up. I have Python projects and I would want to save it into the deep learning folder, and I will create a new folder called detailed, MNIST detailed, and this document will be saved there. So deep learning, MNIST detailed, I will come back to deep learning. You will see that a new folder is created. This MNIST detailed, you click here. This is the Jupyter notebook which we have just gone through. This is everything what we really have here. So you could use this, run on your own Colab and follow this video tutorial, and that's going to make you understand everything what we have covered. So in this tutorial, I have shown you the detailed explanation related with MNIST problem. We started with MNIST problem as it was explained and in the Keras documentation. We took that problem, we created a new Colab Jupyter notebook. We ran first time as it is, and after that we took every step, every line of Python code, and we expanded and we learned what is happening from start to finish. And we also took the help of CNN explainer to understand each layer, and whenever the code was running between layer, the whole model, network, the inputs, outputs, parameters, we all understood the activation, the different functions such as activation was happening, or the max pooling, or the flattening, or the dropout. All that things we have understood in this tutorial. Objective was that you should be able to understand really nicely that MNIST example which we have solved using our Keras example, how it is done. And once you understood that, now you could use your own input data and you can create your own network, so you could build your own solution, and if needed you can use the help from CNN explainer to explain that to somebody else. So that's all I have for you in this tutorial. Once again, thank you so much for your time. I do appreciate it kindly, and I'm going to look forward to see you in my next video. Until then, thank you so much.